Hello, everyone, and welcome to another exciting episode of Innovation Coffee. My name is Robert Wolf, and I am the host of this weekly live stream. And today we are going to be meeting with Ricardo Mendoza, who is the CEO and co-founder of a company called Pantacor. Now, we have a lot of exciting things to talk about, as you may have read in the title of this particular episode. We're going to talk about the future of the Linux distribution. There's a lot of really fun stuff to talk about. We have excellent questions prepared. Of course, as community members here, if you're in the YouTube channel watching, please feel free to post your comments and or questions for myself or our guest here, and we will get them to him as soon as possible. Now, before we dive into this episode, what we like to do usually is talk a little bit about last week's episode, and we also have some news announcements. So let's first talk about last week. Last week we met with Rick96 is his handle, but it's Sahaj Sarup, who is an engineer out of Lenaro, and he specializes or focuses on the 96 boards ecosystem. There's a lot of really fun stuff talked about last week. If you have an extra hour, go check it out. Don't leave yet, but go check it out later on. Rick96, I say Rick, we're meeting with Ricardo. Sahaj and I go way back. So there was also some fun conversation reminiscing on, our past employment together, doing a lot of stuff with 96 boards in traveling and, doing all sorts of cool demos around that. Now, talking about some news stuff that we have going on, let's cue up the news segment. Wow, time goes by so fast. Registrations are already open for the annual ARM Dev Summit. So you can see right here, gotta get used to these reverse on the screen, but devsummit.arm.com. Go check out the website. You can now register for the event. Now, this year it is a virtual event. So, there are a lot of things we have learned from last year. So you'll get access to all different type of platform. You can go register now, get your schedule put into order, all that good stuff. Besides that, I also want to mention that there is a competition that has just kicked off as well. So developer.arm.com/devsummit-competition. Lots of opportunities there to win prizes, upwards of $5,000 for first prize, all the way down to $1,000 for the third prize. Now, go check that out. If you have a team or you want to work by yourself, there's lots of ways to participate in this competition. Now, in parallel with this competition and with Dev Summit, we also launched a new Discord server. Now, this Discord server is intended to not only support you, attendees of the event. We have lots of great channels to get support and interact with other folks that are going to be attending the event. You can also join to get support for general ARM related developer topics. So we have all sorts of cool stuff going on there. Since the registration opened for Dev Summit, that was right around the time when we launched this Discord server. So basically last week, we have already had hundreds of people join. There are some great conversations going on. So don't miss your chance at joining this Discord server. Now, I want to remind everyone that if you enjoy this stream, please like the video, follow us on ARM Software Developers, because we do this every single week at 5 p.m. UTC. You can join us right here. We bring on guests from all over the ecosystem and talk about interesting topics, like today's topic with Ricardo Mendoza on the future of the Linux distro. Now, without further ado, let's bring in Ricardo. So, Ricardo, there you are. Hello. Welcome.
Hey, Robert. Hi. Nice to see you again.
Yes, you as well. And for those of you watching, Ricardo and I kind of go, I want to say like at this point, way back. We've known each other for quite a few years, meeting at conferences. And this was back when I think you were with Canonical, right?
Yeah, I think 5 years.
Yeah, 5 years.
When we met.
Yeah. So we actually brought you on to one of the shows when we were first piloting this live stream on the ex-co-host's YouTube channel, Alessandro Grande. We brought Ricardo on to talk about similar topic as today. We're going to dive a little bit deeper though. So Ricardo, people may have not seen that last episode that we did. Could you maybe just give us your origin story? Tell us a little bit about yourself so we can get that on record.
Yeah, no, absolutely. That was a bit over a year ago, I think. So absolutely, you'll need a refresher. So Yeah, like Robert said, him and I, we go back a long time. He did mention we met when I was working in Canonical still. That was 5 years ago since I've been working in since I've left Canonical. Back then, we spent myself actually and my co-founder here in Pantacor. We spent several years working in all types of embedded projects within Canonical, and different both private things as well as, of course, public domain things you might have heard of, like Ubuntu Touch, and different associated projects, even Ubuntu Core in the last year of our tenure there. And we've always thought that the embedded ecosystem has sort of like been, from a software point of view, has been lagging behind quite a bit from all the goodies that the rest of the technology world are bringing to the ecosystem of Linux, right? And we've always, it's always been our bread and butter. I myself, I've spent, I don't know, I've been maybe more than 15 years involved with different embedded projects. I think the first thing I ever did was take part in early days embedded architectures like ARM and MIPS for handheld PCs. That was great times in the early 2000s, and just porting Linux kernels back and forth. And it's always been, what I've done. It's my DNA. And we decided to take this plunge into setting up Pantacor about four and a bit years ago, to help that embedded ecosystem just get better tooling, get better technology, right, to realize the product visions that are required at the moment to go to that super connected IoT future that all the high level executives keep pitching at us, right?
It's funny because you mentioned this kind of like connected world, and I remember when I first got into the industry. So I was a little bit of a late bloomer here, right? I mean, I graduated college in 2015, and I graduated with a digital signal processing degree in electrical engineering, and I had no idea that I was going to get into Linux and open source when I first graduated. Sure enough, there I was with Lenaro. And I remember working with Qualcomm when they were pushing out, this was the year that they pushed out the Dragon Board 410C. And their whole idea, the whole thought process, and it wasn't just them, obviously, the Internet of Things, right? People need to be able to develop long-term to basically put these devices all over the place. And so, right now you can kind of say like, well, we're super connected through our smartphones, these mobile devices. But I mean, what happens when every single traffic light, when every single stop sign, every single thing that you pass in the world on your day-to-day is connected in one way or another? And, we're not there yet. Right. But, there are companies, imagine like yourself, that are building out this infrastructure to put into place so that we can have this more connected world in the future. Very nice to meet you. Very nice to meet you again on camera here. Yeah, cool. So that being said, Ricardo, we are here to talk about the future of the Linux distro and Panticore, what you're doing to enable this or get this going. So maybe first, before we dive into the topic at hand, tell us a little bit about Panticore. What do you do at Panticore? What does Panticore do for the ecosystem?
Yeah, absolutely. So over at Pantacore, we basically build open source technology to help manage, control, develop embedded systems, right? Embedded Linux systems, that is. Right? What does this mean? This basically means just give developers the right tools for them to accelerate their development processes for companies of all sizes, from large 10,000 employees to the small 5-person startup trying to bring the next thing out, right? To be able to go to market without having to have that sort of headache at the end of the product cycle of, how do I manage my systems? How do I keep my things updated? How do I create a development architecture that lets my business scale, right? Both from the development point of view as well as the product operations point of view, right? That's basically what it is, right? So we create something called Pandavisor, right? About 5 years ago, that was the brainchild of myself and my co-founder early on. We, actually, good anecdote is that we actually started this with a very reduced, with a very narrow focus on the telecommunications industry, right? We thought, customer premise equipment, things like Wi-Fi routers, access points, set-top boxes, everything that everyone has at home, right? That is actually a full-fledged computer running Linux. It is currently managed in a such archaic way, let's say, something that feels out of the 90s, the type of the technologies that are in use there, and we hear all these painful stories of, like Deutsche Telekom or something like that getting hacked for 20% of their, or 5% or whatever of their footprint, installed footprint, and botnets taking over, and the inability of just seamlessly upgrade a Wi-Fi router without it breaking in like 10 or 15% of cases, right? You would think that in this day and age that would be a solved problem, right? But it's not. So we took that approach first and foremost in that industry, and from there we kept growing, right? So it's about making sure that we really take the approach of understanding the baseline embedded, right? Not the high specifications, big boards out there, but actually the down to the bolts embedded, the NAND flash, NOR flash kind of devices, right?
Nice. So, and you mentioned that you started this company about 5 years ago, and I'm sure that things have evolved since then. I want to start diving in now to the topic at hand. So we're talking about the future of the Linux distro, and you've kind of slowly started segueing us into this. But I have my first question here, and it kind of hints at what you feel is where we're headed. But my first question is, where do you feel the Linux distro is headed? Do you feel that it's still relevant? Is it not relevant anymore? And I want to kind of focus on what types of developers. We're looking at like embedded developers, maybe even developers working in the cloud. What are these engineers going to be expecting in this future of the Linux distro?
I think we're heading to a world where all of these developer groups that you just very nicely put in individual silos start merging together. This is like in the, I don't know, in the 80s or something. Somebody that was working on a mainframe, those people had absolutely no idea what the business side was doing. But nowadays, like companies just sort of merge together. Like technology, software development is just part of the business logic itself of a company. You would say it's no longer an ancillary external service, but it's actually part of its DNA, right? I think in the combination of these different segments you just said, the embedded developers, cloud developers, whatever else, right? I don't know, distribution developers, whatever you want to call it. Like all these people are merging together towards one goal, right? Because I don't think we can realize that future of everything is smart, everything is connected, right? Just by thinking, okay, well, then the devices are in the hands of embedded engineers of old. These are the people that have been doing Wi-Fi routers for the past 20 years. No, I think it's actually, we need to be able to open the floodgates, right, for developers of all segments to interact in the embedded industry, right? The embedded industry is what's going to take us into that next level of connectivity, into this vision of that connected world, right? So we need cloud developers, we need all types of developers to be able to, seamlessly interface with a device, right? In the same way that you just spin an instance somewhere and start developing your cloud application, right? I think once we break that, once we close that gap, that's when we're going to see exponential growth into this idea of IoT that we keep hearing about, right? Yeah.
So when I hear the word distro, I mean, I think all the way back, right? Like you look at the distros that are the most popular ones: Ubuntu, Fedora, Red Hat, RHEL, and I start to think like, okay, well, as a developer, and this still happens, right? Like you get a device and you say, okay, well, what distro am I comfortable with? Say I'm comfortable with Ubuntu. Okay, well, I want to get Ubuntu onto this device. Well, what if Ubuntu isn't enabled for this device? Now, in a lot of cases, that usually is one of the first ones that gets on there. But what if Ubuntu isn't enabled for this device? I guess I'm trying to kind of like wrap my mind around what you're saying here is, if the Linux distro is no longer relevant and we are all kind of this big melting pot of developers, we get a device and the distro should not really matter. We should just be able to develop. Or are we not seeing the distro at this point? It's just working.
Right. So it's not so much that the distro is not relevant, but you hit the nail on the head there when you say, I open up my box and I take out a Raspberry Pi and I say, okay, I want to run Ubuntu on it, right? Or I want to run RHEL on it, right? And then you start going through the motions. Okay, how do I get it, and so on? How do I get it in there? Is it supported? It's not supported. Does the Wi-Fi work? The Wi-Fi doesn't work. The LEDs don't work. Whatever, right? I mean, the CPU frequency governor is not working. All these kind of things, right? But you're not really interested in that. Why are you looking for Ubuntu? You particularly. Why would you be looking for Ubuntu? I think the answer is because you're comfortable in that development environment, right? But that's it, right? It's not exactly because it runs better than the other one. It's just because you as a developer, you're comfortable on it, right? So what I mean is that I think in the future, and we have seen this, on the cloud. We see this on the cloud all the time, right? We see on the cloud that nobody really, it's not that they don't care, it's that they just take for granted the fact that cloud infrastructure runs, right? And everybody then just uses their distro of choice as the starting point for their application containers, right? That's it. So you might use Rails, somebody else might use Fedora, somebody out of somewhere else might use SUSE, right? Okay, everybody can choose. That's fine. Baseline infrastructure will enable you to make that choice, right? I think we see the embedded world going in a similar direction, right? Which is enable more people to the why actually, let's lead with a question. Why do you see that split between embedded developers and everyone else, right? I think it's because everyone else thinks in terms of, I'm more comfortable with this distro or that distro, whereas an embedded developer usually doesn't even think in terms of a distro, right? An embedded developer will go, will often use a specialized or a stripped down version of a firmware building system or a distro itself, something like OpenWRT or something made with Buildroot, right? And they will realize with that baseline, they will realize a system that works for one particular function, right? But the reality is that a cloud developer or somebody else, right, that might be comfortable with a distribution environment, would prefer to use that as the segue to then be able to create applications for disconnected devices, right? So it's not that the distro is not relevant. No, the distro is more relevant than ever for application development, right? To actually open the door to developers to make that choice of, I prefer to work on Ubuntu, I prefer to work on Gentoo, whatever, right? Up to you. Just like the cloud has allowed them to do, right?
Gotcha. Now, I perfect answer, by the way. I just noticed you pull up a piece of hardware from your desk, and this reminds me of a segment that we have here that we're going to address now. I surprised you there, I hope, Ricardo, because we were supposed to do that earlier.
Yes.
So you pulled up some hardware from your desk. We'll
what I pulled just a normal Pi. You know that one, right?
Yes. What else you got there? Do you have any other cool stuff on your desk?
I do. I mean, so remember I mentioned at the beginning that, where we started was with actual telco equipment, so customer premises equipment, Wi-Fi routers, right? Most of the Wi-Fi routers of the world are powered by different Qualcomm Atheros chips. And this board in particular is one of the ones we use the most for customer demos, for actual deployments and things like this. This is a Dakota clone. Dakota is one of the main developer kits that Qualcomm provides for their QCA, for their IPQ 4019 and 4029 lines of chips, right? Now, the interesting thing of this is that a lot of people think about embedded, right? Depending on the audience, of course, but a lot of people think about embedded and they might think more about a Raspberry Pi, right? But this is a Pi 4. In fact, this is an 8 gigabyte Pi 4, right? 8 gigabytes of RAM. Imagine that. That's half of what my laptop has, right? And it has dual HDMIs, all the usual culprits, right? This is massive. This is almost as good as my laptop. My laptop is not that great, right? But this guy on the right, however, is 128 megabytes of NAND flash, right? Without a flash translation layer. That means that it's not an eMMC like you would be used to when you put an SD card inside of a Raspberry Pi. No, this is completely different, right? This is block address NAND. This has all the pains and headaches you can imagine. This doesn't use the ext4 or the normal file systems you think about. There's more UBFS, SquashFS on raw NAND, things like that that might be completely foreign to a lot of developers nowadays, right? But 128 megabytes of storage, 256 megabytes of RAM, right? And you use this to power AC Wi-Fi for your whole home, right? Or tens of this to power a whole office or supermarket or whatever it might be, right? This is the type of embedded equipment that is our baseline, right? Our technology runs all the way from this to the huge devices you can think about, right? But yeah, this is our bread and butter, right?
Awesome. So yeah, it's fun sometimes to see what kind of devices our guests have on their desks. So cool. Thanks for sharing that. Now back to this topic, future of Linux distro. I want to talk about some of the unique criteria that embedded devs are working under when it comes to their particular distro. So you were kind of like, I want to say, grouping these people up, right? I grouped them up into their silos of developers, but then you kind of said, let's regroup these. Distros are important to application developers, and then everyone else can kind of be independent. But then we have this question here saying, what are the unique criteria that embedded developers are working under when it comes to their distro?
Well, I mean, so once again, most embedded developers, well, not all of them, right? I mean, it's not generalized, but embedded development for actual end product development usually doesn't follow a distro line, right? You might use something like a distro, like, for example, we know Linaro has done several, let's say, reference distros and things like this for people to build on top of, right? But not all boards, not all chipsets actually support these kind of things, right? So you do find that a lot of developers just end up building out their own, right? And they highly customize it just for the use case at hand, right? And that was fine, because usually there was one use case per device, right? Devices were even often not even connected, right? But as we go into a world where devices become just more generic infrastructure, and they have to then customize themselves depending on the use case where there might be, right? It's not the same, I might be, I don't know, Samsung, right? And I make all the way from washing machines to TVs, right? And perhaps across the board, right, even though I might have 500 different product lines, I will only have, a handful of boards that power all of these pieces of equipment, right? So it is no longer only about what distro is best for each board, but rather how do I make each one of those boards from a software point of view as modular as possible so that it can apply anywhere, right, in my product line. Does that answer the question?
Yes. Oh, absolutely. Yeah. And so this actually leads into, I think, my next question here. Again, feeding off of the things we've discussed so far. How often does this philosophy, the philosophy of where the embedded developers and what they're doing, extend to infrastructure and the cloud? So how often do these paths kind of cross, and where you can kind of say, okay, I'm an embedded developer, but I feel equally as comfortable or working in cloud and infrastructure?
I don't think they cross way too much at the moment, not in a very organic way. I mean, I think there's a lot more push to realize this because of where the industry is going. So you see all the big companies actually require more and more as soon as they open the conversation to, hey, we need to the next generation of our product. This is the typical thing that a product manager will come in the room and say, hey guys, the next generation 2023 needs to be connected. And then everyone is like, what does that mean, right? It needs to be connected, it needs to be modular, it needs to be IoT, right? And then everybody's like, I have no idea what you just said. And then okay, fine, that's the first step. But then you start thinking about what it means. What does it really mean, right? It means something very simple. It means being able to control your system in a modular way, right? It means that you need to stop making vertical silo products, right? And instead creating a more, let's say, homogeneous software architecture that can cover all of your product lines, right? So that your operations, your developer operations, your DevOps, whatever you want to call them, can go at the next level of speed, right? You cannot develop a product that might have ever-changing functionality, ever-changing features, new features across the lifetime of that product unless you have the underlying infrastructure to enable that, right? You need to be able to quickly migrate, to quickly change, evolve your code bases in a distributed manner so that all your teams can contribute, right? But your baseline infrastructure stays the same, right? And that's what the cloud has achieved. So I think the mentality, the embedded world is sort of like evolving towards that mentality of the cloud world, while the cloud world is also, from the other angle, trying to understand what does it mean to go down to that world of devices, to go away from the ephemeral world of the cloud to the world of devices, right? I think I'm sorry if I go a little long, but I think there's a trend right now that there's a lot of people just taking the concepts of the cloud and applying to embedded, right, one to one. And this is, this is like cats and dogs. Yes, they all have four legs, right? But for those that have cats and dogs, they know that they're vastly different animals, right? You cannot just take one and mix and match with the other. The world of cloud is an ephemeral world. You create instances, you create infrastructure, you scale it very independent of your own notion, even of where that infrastructure is running. You just scale on demand, right? But on the world of embedded, of connected devices, if my Wi-Fi router fails, it failed. And that's it. I cannot scale it. I'm going to scale out the Wi-Fi routers in the home. No, that's not it, right? Scaling out means buying more and plugging them in, right? And if I only have one and it breaks, it means sending a technician, which already voids the benefit that you might have taken from that router over a 5-10 year period, right? So, it's a vastly different business proposition, business model, one end and the other, but they both have very similar application needs, right? And that's where the magic is. What can we provide that allows both of those worlds to bridge together, right?
Okay. So let's talk about the complexity of these distro management, right? So distro management and the complexity of managing these distros. So I guess my question is, when you bring in all these distros, right? Like sometimes you'll have access to a specific library with one distro that you won't have with another. And this comes into, these distro managers or distro developers who are enabling the libraries, bringing them into their package management systems, things like that, right? But when it comes to the complexity of making sure these specialized libraries are available, these components are available, or whether they're not available, right? How does Panticore, how do you manage this complexity? How do you keep fleet secure with these systems?
Remember, we don't build the distro, right? So we don't solve that problem for users. We just give them a way to develop their applications independently. If somebody wants to use Ubuntu, fine, they have access to library A, B, C, it versions with patches, whatever, right? Somebody then might, on the same device, use something else to develop or provide a different application. Now, it's up to the system designer, to the system architect to make those decisions, right? What we let them do is remove that pain of vertical integration, right? Which is actually the part that ends up taking a long time, right? Because we always think about the complexity being a problem, right? But in reality, what the complexity does here in vertical integration in embedded systems is not even that it makes things slow. It's just that it prevents innovation of any kind. It prevents, the monolithic firmware prevents innovation at the feature level on connected devices, right? As devices become less, single feature or, like purpose built, they require more and more features. And features actually come from vendors, right? People, when we say developers and people writing applications, we actually mean vendors, right? People that actually provide the little stack that is going to give you secure VPN access over WireGuard to something. Tailscale, for example. I don't know if you know those guys. They're very great, right? And on the other hand, you might have something for IoT management that is maybe built off of Home Assistant and so on. Well, guess what, right? The Tailscale client has clashing libraries with Home Assistant, right? That's not a problem that is easily fixable within one silo, right? That's why we take that containerized approach, right? So we just provide the infrastructure to make that dance of containers easier, right, for the developer and the product architect, right? That's all. But of course, the architect has to keep in mind what the clashes might be at a feature level, right? So an application steps on top of another one. Well, it's still up to the product architect to figure that one out, right?
So you brought up containers, right? It's the first time it's mentioned so far on the show. You brought up containers, containerization. This has been a buzzword for many years now. I remember total events basically revolving around this whole container thing, right? Let's kind of bridge into this topic. What does a Linux framework for building containerized systems do?
Right. So we think that on the embedded ecosystem in particular, a device is defined by its features, right? It is not defined by, is it running a Linaro reference distro? Is it running Ubuntu? Is it running SUSE? No. It's actually defined by its features. If you think of a Wi-Fi router, well, what is its main feature? Routing. That's it. You don't really care if it's OpenWRT, if it's a Qualcomm SDK-based solution, if it's Broadcom SDK. No, you want it to route, right? That's it. I want to do Wi-Fi operations and routing. In addition to that, it might have other features, such as tunneling. It might do automated VPNs for you, right? So that you can connect to your office network or whatever it might be, to your corporate VPN, right? It might do quality of service, right? So that, during between 8 and 5, Zoom traffic is prioritized because you have your kids with the tablets, right? And then between 8 and 5, if I'm using the same network to do my work calls, then, okay, maybe that's an issue, right? So now you start to think about, it's not only Wi-Fi routing, it's also other features, right? So the software needs to chase that notion, right? If the notion is we need to define the device in terms of its functions, then the software needs to enable that, right? So we said, okay, instead of having a container engine inside of a big distro, inside of Qualcomm SDK or Broadcom SDK or OpenWRT or whatever, why don't we actually have a very bare metal, and by bare metal I mean, at the first level of Linux booting, let's say, that all it does is bring up containers and maintain that blueprint of the containers that are running on the system and how do they interface with each other, right? So let's do away with that notion of a big bloated distro whose only purpose at the end of the day is going to be to run a container engine, right? To bring up applications. Let's do away with the bloated concept, right? And actually focus on providing the bare minimal life cycle manager of containers, right? That does nothing else but set up containers, right? So something, in our case, Pandavisor, then it does the job of setting up each one of those functions that I just mentioned. Pandavisor comes up, but it doesn't set up networking, it doesn't set up anything, it doesn't set up modules, drivers, no, it doesn't do anything, right? The only thing that it does is start the relevant containers that will take care of each one of those areas. Your Wi-Fi and routing container, which will then, of course, start up, instantiate, and enable all of your PHYs, your routing equipment, whatever it might be, your ETHs, all the things that are on that board, right? And then all the other containers that might bring up other user features, right? That's how we have seen the world of developers in this segment sort of moving towards, right? And we've created these tools to help that need, right?
I love it. It's so, I mean, this brings in so many more questions, right? But like, I guess this kind of, you're talking about Pantavisor as kind of like this layer that you can stack containers onto and kind of avoid, in your words, kind of the bloatedness of a full-blown distro, focusing on the components that you're most interested in for the device that you're working with. Now, the question is this a distro? So like, I mean, are you calling this a distro, or, and if not, then how is this different from a distro? Because I mean, it almost feels like you're eliminating the bloatedness of a distro, but we're replacing it with this. So is Pantavisor a distro in a way?
Well, that's the thing, right? I mean, if we have to think about what is a distro first and foremost, right? Distro in the historical sense of the world, a Linux distribution is a curation of packages, right? It's a curated experience that gives you everything you need to consume Linux, right? So it's not just a kernel; it's a kernel plus everything else, right? Kernel is just a tiny bit, the most important one, but it's tiny, right? So it's this curation. How did distro start? Right, in the early 90s, then Red Hat created the Red Hat Debian came up, and both of them just said, okay, let's package everything from Free Software Foundation, from GNU project, and so on, and then let's put it all together so you can actually have a full running system. But at that point, a full running system meant a POSIX compliant Unix-like shell that had a bunch of tools, all the usual culprits. You could go in there, do activities, code in it. You could write code, compile it, run programs, right? But in our particular case, we're not doing that, right? You could argue that Pandavisor Linux, because actually, I don't know if you remember, 1 year ago it was just Pandavisor. Right now it's Pandavisor Linux, right? Why? Because, well, okay, it is much easier to explain. Your question is the best question ever, of course, right? And believe me, we spent several cycles trying to think, how do we convey that message that we're not exactly a distro, right? But we are definitely a Linux flavor, right? We are a way of doing, we are a new way of doing, of creating Linux systems, right? When you're going to architect, design, and develop a Linux system, using Pandavisor Linux is a starting point that lets you leverage existing board support, right? So existing board support packages that are delivered, managed, and lifecycle managed via Pandavisor, so that you only have to care about the applications that you're going to be putting on top, right? That's basically what it is, right? So the moment you unlock, you sort of move away from the concept of the bloated distro, you start thinking in modular functions, right? You start saying, okay, you know what? I'm actually going to take that networking container and use it for my project. I'm going to use Robert's networking container or Sahaj running networking container and use it for my project, right? Because I know this one is cool. I know this one is more embedded feature. This one is better for Wi-Fi. This one is better for 6LoWPAN, whatever. You can start thinking in those terms. Imagine if instead of just thinking, what web server am I going to use? You start thinking, what networking container am I going to use? That this opens so many doors for software development on embedded equipment, right? That I think it's great, right? Because it also opens that door for collaboration, right? You have seen what containers have done for collaboration on the cloud, but not only containers, other packaging formats like things like npm, pip for Python. Like, it is so easy to just consume pieces of the puzzle, right now in that sort of higher level development. But that does not exist in embedded, right? And that's what we're trying to address here, right?
Yeah, so I mean, I like that, but by the way, if you are choosing between something I built versus
I'll go
something
for Sahaj,
Sahaj built, pick Sahaj's. Mine's broken. No, there's a really good question that popped up here in the chat. Is this related to Yakdo? And when I think about Yakdo, I kind of think about it something like this, right? But Pantavisor Linux sounds much more streamlined, right? So when I think of Yakdo, you think of the different layers, you think of building out these recipes. You're building a custom distro for your device, but you have to go through this whole process: bit bake, build, get your ISOs, flash it, all this kind of stuff. So maybe, addressing this question, is it related to Yakdo? So please answer, if you could, the Captain 32's question, but also maybe could you elaborate a little bit on, and I know you already kind of did, the differences in what I was just talking about here.
Yeah. So it's not related in the sense that the projects are not related, right? But several of our customers and people using the technology actually use Yakdo to build this custom feature containers that I'm talking about, like a connectivity platform, right? But because that's the point, when you use Yakdo, Yakdo is beautiful to build that userland, that rootfs that does exactly what you want, right? And now the question is, okay, how do I manage the life cycle of that thing, right? Then you start thinking, okay, what do I need to integrate into that build to make it manageable and so on? And that's when it gets slightly complicated, because at the end of that process, you might think, oh, now I have a purpose-built system again, right? That's not what I wanted at the end of the day. I wanted something that I could drop and replace that Yakdo build thing with something else, or mix and match it with something that would add extra features, right? So, several of our customers do use Yakdo. Well, actually, most of them, 90% of them, let's say, use Yakdo to build these application containers, right? That provide the full logic, the different modules of logic that are going on the device, right? And what we provide for them is, of course, easy integration layers with the Yakdo build system, so that the resulting image is an image that is Pandavisor enabled, right? So that the Yakdo build userland runs through Pandavisor, right? So these are complementary systems, right? We need Yakdo. Embedded developers need Yakdo to be able to create those custom crafted userlands, right? But they also could benefit from Pandavisor to make those manageable, smarter, connected, lifecycle controlled. Right?
So then, if users are using, or if your customers are using, the developers working in this area are using Yakdo to build out these you call them userlands or containers. I mean, how is this different from, say, using Docker to build a container? What kind of containers are you building here? How is this different from Docker? And I mean, what are the advantages of using building these types of containers over using, like, say, a Docker container?
Yeah, this is a very important question because it's one of the key things, right? I mean, so we have never run the Docker engine or any OCI compliant engine on the device, right? Because remember what I said first and foremost, right? If you have a Wi-Fi router like this that has 128 megabytes of NAND flash without an eMMC or flash translation layer, you cannot do too many things on that NAND before you wear it out, right? First, let's take the wild guess if something like an OCI or Docker compliant engine actually fit on this device with all of its dependencies and everything, which it doesn't, right? If it actually did fit in a very crafted way, it would take a lot of the resources of that device just to run that engine. And that engine would then need to live inside of the context of that sort of bloated distro, you could say. So at the end of the day, you're doing 80% of the effort only to then be able to run your container engine to run applications at a point where your applications are no longer going to have any resources available, right? In the case of this tiny embedded equipment, right? If you move into bigger things like a Raspberry Pi or something like that, of course, well, resources are more available. There's a lot more you can do, right? This looks more like a server than a real embedded equipment. We all know that, right? But still, if you remember, Robert, earlier I said the cloud is different than embedded. The cloud is ephemeral, right? I just scale my infrastructure. If the server goes down, it doesn't matter. It's a node that went down. I can spin 10 other nodes. It doesn't matter, right? If my Wi-Fi router dies, I cannot spin more Wi-Fi routers. So the way you run software on the device needs to be purpose crafted for this resilience in robustness needs of the embedded market, right? Now, an embedded device cannot go around assembling 20, 50 layers of files all over some type of joint file systems and so on a NAND device that has no flash translation layer, right? So what Pandavisor does, well, not Pandavisor, but rather our tooling, what it does is that it takes containers like a Docker container, something from a Docker source or a Docker file or whatever. So we do use Docker for the amazing, let's say, language that you can use to create a container, right? But at the end of the process, when the container is built, it is exported to a very binary format that Pantavisor can consume, right? Which is basically one or two or three single files that get put on that device that gets sent as objects or assets of the firmware revision that is going to be running on that device and get run by the engine and started as a container, right? So this makes it very straightforward, right? To on a low spec on a very tiny device, be able to make sure you're running exactly what you intend to run, right? When you have, let's say, 2 or 3 containers, in our world, you only have 5 or 6 files on disk, 5 or 6 objects on disk, not 5,000, right? So, the reproducibility, the ability to make sure that you're running what you want is critical to us, and the resilience and the atomicity of how you send and install these objects is the critical part here, right? So we do use Docker, right? But for the actual definition document, for being able to build these containers, for the developer tools that Docker offers, right? But for running containers on devices, this goes through a post-processing step for Pantavisor to understand.
Yeah, so I mean, in general, I kind of want to I want to kind of like a sentence that defines the difference between what you've done with the Pantavisor Linux, right? I mean, because this sounds like a new innovative approach to I want flashing a Linux distro. I mean, like when I get a device, like I said at the beginning of this call, I always think like, okay, well, what distro am I going to flash to this device to kind of get working? But like you've reinvented this. It's a completely reimagined way of doing what you need to do on your device, getting what you need done on your device. And so I guess, I mean, I'm excited. I'm excited to see. I mean, like, do you have a developer network or a place where people are building stuff out and sharing this kind of stuff?
Yeah, so you can go on pandavisor.io. That's a site that we recently put up. before everything was together in our Pantacor story, but we've decided to make sure that Pandavisor itself is as standalone as it can be, right? This is not something that you need to buy into anything or paywalls or sign up for accounts or anything, right? This is ready to go. All of this is open source and is MIT and Apache licensed, right? So you can go to pandavisor.io, take a look at the code. There's some getting started guides there. You can play with it on a Raspberry Pi fully locally. You don't need to connect to a cloud or anything, right? And that's the best way to just play with it and take a look, right? I'll show you in a second the interface that you can see to sort of introspect how these containers run on the device, right? But you just said if you can give me a sentence that defines this or that, right? I think you can think of Pandavisor as an init system that starts your distros, right? So imagine booting into an init system that will start then your distro of choice, distro or several distros, right? As simple as that, right? Pandavisor is that little glue in the middle that lets you take a Dragon board or a Raspberry Pi or one of these routers and say, after the first boot, well, you know what? Actually, I would like to deploy an Ubuntu userland on this thing and use that as my main, right? And that's it, right? Imagine that. If you then extend that process, you can say, well, next to that Ubuntu, I would like to deploy a little RHEL or a little Fedora or OpenWRT, because you know what? Actually, for a Raspberry Pi 4, now there's an OpenWRT version that allows you to do routing on the Pi 4 with OpenWRT. So instead of deploying my Raspberry Pi OS container, I'm going to deploy OpenWRT for the connectivity part. But then next to that, I'm going to install maybe Home Assistant, which is its own little distro, right? And so on and so forth, right? So that's basically it, right?
That's awesome.
It's a different way. It's a different paradigm. It's a paradigm shift, right, of how we think about Linux systems.
A little more than a sentence, but I mean, I think you got that.
Yeah, I'm sorry.
It's okay.
You put it at the first comma or dot.
Yeah, cut it at the first comma. Yeah. So, I think that gets the point across. Awesome. So, you mentioned you have a demo. I just have a few more questions. I want to talk about DevOps right now, right? We talked about it a second ago. You mentioned it. And then we'll go into this nice little walkthrough you have planned. So how does this lead to the adoption of cloud native and DevOps practices in embedded development? That's the question. So let's focus on the DevOps aspect here.
Yeah. So Pandavisor has an interesting thing we haven't mentioned yet, which is that in the same way that we control the life cycle of these application containers, we use the same protocol, mechanism, and definition to control the life cycle of the BSP, right? So your Linux kernel, your modules, any static firmware you might be using, any configuration for that BSP. So Pandavisor itself, in the same way that you can deploy an application, you can also deploy in the same step and update to that BSP. So you can quickly think how having, let's say, this is a Pi 4, right? This is a Pi 4 is an ARM chip. This is a Qualcomm board. It's an ARM chip. Both of them are Pandavisor enabled, right? Because they have the baseline Pandavisor enablement layer, well, they have different BSPs, right? But the applications that I deploy here or there are the same, right? So from the application perspective, the infrastructure is homogeneous, right? Of course, there will always be certain details, bits and pieces, right? It's in like, okay, well, this one has a 5 gigahertz AC Wi-Fi, the other one does not, things like that, right? But these can always be expressed by the system architects, right? So what I'm saying with that is having something like Pandavisor brings to the embedded world the agility of DevOps, because it lets you have a common infrastructure base across your different product lines so that your teams, your developer teams and so on can focus on what really matters for them, which is the business logic that is going to be running on top, right? This creates a huge different future for the embedded ecosystem, right? It might sound obvious to cloud developers, to people creating massive scalable backend systems, right? Because for them, it's already mantra, right? It's like the infrastructure doesn't matter, right? I mean, I just throw things at the cloud and it scales, right? And I develop my applications without worrying too much if they're running on this architecture or the other architecture or whatever, right? These are problems for the people actually scaling out the infrastructure. But on the embedded world, you would be surprised, but it's still, very vertical silos of how you develop the software that runs in each one of these products, right? So once you have the ability of defining all of your product infrastructure, product A, B, C, D, all run in Pandavisor, and at that point, you have a team that is in charge of the BSPs across the board, and you have another teams which is in charge of each one of the business logic bits and pieces, the modules of business logic, then the speed at which your industry moves just goes tenfold. As simple as that, right? We've seen it with customers, right? And it's amazing. It's beautiful to see because, people start collaborating easier. As simple as that. You start talking about, you start sharing containers around that end up finding their way to a factory somewhere in Shenzhen, right? And coming out in a board that then, it reshapes itself thanks to the system. In the last step, it says, I need container A, B, and C, or C, D, and F, because I'm going to that product or that product, right? It just makes everything so much easier, right?
It sounds like a very strong path to product approach here.
Yes.
So, I mean, I can picture this. I mean, working with 96 boards for so many years back in the day, I mean, I remember we were really trying to tackle this problem, right? I mean, you're working on, say, one board, you have a product that you want to get out the door. I mean, you only have so much time to get this product out. And if you start developing on one board and then realize that you have some sort of constraint, and then you're like, oh, shoot. Well, we developed on the wrong board. We need to move over to this other device with more RAM or with, bigger storage or whatever, different IO. And so next thing you know, if Pantavisor was enabled on all these boards, then you have the ability to seamlessly transition your work over to another device with Pantavisor on there, drop these, LXC containers on there and get running, right?
Exactly.
So I mean, I think that's pretty awesome. And again, this was a problem we were trying to tackle for years. And so there you go. Panticore with the Pandavisor Linux comes out to save the day. Let's see here. It looks like some more things popped up here in the chat. But while I check those out, Ricardo, why don't we dive into your demo, your screen share here real quick, and we'll see if we can get that out of the way before we run out of time, because we only have about 7 minutes left.
I'll give you, I mean, this is not so much a demo, but rather a quick teaser of what you would see if you install what you get on Pandavisor.io. Let me see if I can actually share the screen with this streaming system.
Yeah, we didn't have a lot of time to test this out in the green room beforehand. But yeah, so I'll read a comment here real quick from David W. David W says, you could develop in a container on a low-cost board and deploy to a hardware container environment, like for automotive. Yes.
Was that a question or?
I think it's just a comment. He was just commenting. David W is our resident automotive enthusiast, automotive and autonomous enthusiast. So, yeah.
No, I mean, absolutely. That's what it is, right? Develop here, moved from this board, this development kit to the other one. You might have a production type of board, a developer type of board, both of them enabled with Pandavisor. You can move your business logic modules from here to there seamlessly, right? You can share with other people in the development team, because these are things I'm not going to get into right now. You can take a look in Pandavisor.io, but you can, every device that is running Pandavisor, you can actually share, right? You can connect it to the cloud, and you can share it with your peers, right? You can say, hey guys, so here's my version XYZ of whatever, I would like for you to test it, right? You share it with Robert, share it with Sahash, and now they have access to clone from that device the modules, the BSP, the software that is running in there, and install it on their own, right? For testing, for commenting, for giving you feedback. This is extremely powerful. I cannot emphasize how good it has been for our customers, right? To be able to do that, right? Because before it was, let me actually download this 32 gigabyte zip file of a disk image so you can flash it, and then they flash it and it's all a mess. It's not reproducible, right? This makes it so much easier. Anyways, can you guys see my screen, Robert?
Yeah, we can. It's up there. Yeah, let's walk through this.
Right. So just very quickly, 1 minute. What we have here on the left is basically serial console and a Pi 4, right? ARM64 Pi 4. This, there's a default login here. This is what you would get if you flash it right now. Follow the instructions from Pandavisor.io. This is the developer toolkit, basically, to interface with Pandavisor enabled equipment and for people to get familiar with it. So you can play with it, do whatever you want, right? On the right-hand side, I've already SSH'd into the same board. When you SSH into the board, it gives you some extra information up here, like your IP address, board identification, things like this, and tells you to run a command called Pantavox. When you run Pantavox, this is basically a Curses built interface the state that Pandavisor is currently running on that device, right? This basically lets me see things like, what containers am I running? In this case, I have 3 containers in a board support package. I can go to this AW Connect. I can find out that this is a container reference from this Docker source built by us, by Pantacor. This provides Wi-Fi connectivity for the Pi 4. This is kind of like what I was saying before, Robert, about do I use Robert's or Sahaj's connectivity platform? Well, you can use ours too, right? This provides several things like captive portals and things like that, right? You can take a look at for example, the board support package that is running, right? This tells you where it's coming from, where is it getting built, right? It's for the Raspberry Pi 4, the manifest and the version it was built against. And of course, on the same page here, you can see the different containers that are running, right? You can do a few other things, like you can install containers, you can add from a Docker source or from another Docker repository source, or from another Pandavisor device that has been connected to the cloud. So I can basically take a look at any of these other devices here that we have by default that let you see, let you pick into the containers that those devices have, and I can copy from there. I can see that on my device, I already have PBR SDK, Avahi, and AW Connect. But this other device has a WireGuard VPN, it has a Tailscale client, Nextcloud, and Home Assistant. I could take from any of those guys and basically install it, right? I'm not going to do that right now because it's a time-intensive process, but you guys can do it yourself if you actually go to pandavisor.io and follow the instructions. There's a lot of other things over here which are covered by the guides on pandavisor.io, like how to get your SSH keys, edit the configuration of each container, configuration of the BSP, claim your device so that you can connect it to the cloud, edit user metadata, and several other things that you can find information for on the website. And I'll leave it at that because that was already the 3 minutes I said it would take.
Awesome. No, I like it. It's funny. I just realized, just to let you know, anyone watching or yourself, like it may look like I'm not paying attention to the demo because I'm staring right into the camera the entire time, but I have a teleprompter. I'm actually looking at everything that you're doing on the screen, the entire StreamYard thing up here, right at the camera. So I was paying attention to the demo. That's very cool. There you go from Alan Robinson. Cool episode. More OS episodes, please. Yeah, of course, we'd like to do that. So this is the time of the show where we start to wind down. And Ricardo, you've earned a shameless plug at the end here. So this is your call to action. What would you like to tell the people watching to go do after we close this out?
Yeah, no, absolutely. I mean, I would like for people to go to pandavisor.io, as simple as that, and take a look at what we have set out there, right? Everything I just mentioned is outlined in there. You can take a look at our company website as well, on pantacor.com, but stick to pandavisor.io. This is the developer tool, right? You can, everything I just showed there, you can complete yourself. You can get images, install them on your Pi. There's a few other supported boards, of course, right? You can go on our GitLab, gitlab.com/Pantacor as well, right? Take a look at the code for everything that is happening in all of our products, right? And yeah, follow us on Twitter as well. This is @PandaHub. Actually, I don't know if it's mentioned, but there you go. Twitter @PandaHub. Make sure you follow us there for updates, for all the different content that is being published at the moment. There's a lot of cool things happening this month, and also for those of you that might be going to hopefully to the conferences restarting after the end of this summer. I hope to see you all in the different Linux Foundation conferences, and hopefully, we can meet and grab a beer. Right? Happy to always discuss embedded with everyone, and let's go. We do it with Robert every time we meet, so the more the merrier.
Yes. Ricardo, gosh, thank you. It's so good to see you. Glad to hear that everything's going well over there for you. And yes, oh my gosh, do I look forward to hanging out with people at conferences again. Jesus. People, yeah, I think a lot of times people don't realize, especially some of my family members and friends, it's like, oh my gosh, you're traveling all the time, going to all these places and hanging out, and you say, let's meet and grab a beer. But in a way, we're not like meeting and grabbing a beer and talking about what we did on the weekend per se. Like we're talking business. Like you're working at these conferences from 7 a.m. while you're having breakfast with your colleagues, you're working. And then all the way until like 11 p.m. when you have that last beer, it's all work. It's all work in some play, you know?
It sort of merges together, however, right? I mean, we all make friends there. Those beers are not all only about work, right? I mean, it is work conversation, but it's with friends, right?
Yeah.
So you make very strong friends there. Like you said at the beginning, we met 5 years ago, and we always catch up when we have a chance, right? And just like that, these conferences are a great space for everybody to meet, right?
Do you plan on being at the ELC up in Seattle in September?
We plan to be at ELC, yes, absolutely. We're going to be there. I think we're going to be sponsoring even. I don't know. Need to check with the team. But yeah, we'll be there. You guys, I'm sure you'll be there as well, right?
I'm trying to get there. Yeah. So it'll be that
actually, wait a second. Pantacor will be there. I don't know if I can be there because the US still hasn't opened up for Europeans, right?
Yeah.
But we'll definitely have people there from our US team.
Cool. Yeah. I mean, I want to be there. So the two events that I'm looking at, obviously, of course, separate from Dev Summit, is the KubeCon in LA and the ELC OSS Summit in Seattle. So those are the two that I'm looking at this year. Hopefully I get to make it to them.
I think ELC is going to be great because it's sort of like been building hype for the past few virtual events. And then they also like merged together with the one that was going to be here in Europe, right? So everybody, if it does happen, I hope it does take place. If it does happen, I think it will be explosive.
Yeah.
Everybody will go.
Definitely. Cool. Well, we went about a couple minutes over here, Ricardo. Want to be conscious of your time, of course, the time of our viewers. So thank you so much for spending it with us. I know it's valuable. We appreciate it. And everyone watching, thank you so much. We'll be here again next week, Thursday at 10 a.m. Pacific, 5 p.m. UTC. Don't miss it. We do this every week. If you enjoyed the video today, this live stream, make sure you like it. Like the video. There's a little thumbs up mark down there. Hit that like button. And don't forget to follow us on the ARM Software Developers YouTube channel. So Ricardo, once again, thank you. We'll see you next time. All right.
Thank you, Robert. And thank you everyone for listening in.
It's Pantacore. Go check out pantavisor.io. We'll see you next time. Have a good day.
Bye-bye, Robert. Bye.